Hi guys, it's Rumi, a math person. Today I'll be going over the basic of interest theory for exam FM. So starting off with question 1.1. If you invest $3,200 in a saving account on January 1st, 2004, on December 31st, the account has been accumulated to this number. What is the annual interest rate? So as we know, the formula is going to be your A of t plus 1. So the later date minus the initial divided by the initial to find the annual interest rate. So then in this case, it's going to be 3294.08 minus 3200 divided by 3200, which is going to be equal to 0294 or 2.94%. For question 1.2, if you borrow $12,000 from a bank, the loan is to be repaid in full in 1 year time with that amount. What is interest rate? So as we know, the formula is going to be a t plus 1, the later one, date minus the initial to find that interest amount paid. So then it's going to be for part A, 12,780 minus 12,000, which is going to be equal to 780. For part B, it is what is the annual interest rate? We know that it is the interest paid on the loan divided by the initial amount, which is going to be 12,000. So this is going to be equal to 0.065 or 6.5%. Question 1.3. The current interest rate quoted by a bank is 9% per year. You open an account and deposit $1,000. Assume there are no transactions on the account, such as depositing or withdrawing. What will be the full amount at the end of the year? That is going to be, this is an easy one. It's just 1,000 times 0.09, so that's going to be yet 9%. This is equal to $90 that they pay in interest, so the amount at the end is going to be 1,000 plus 90, which is equal to 1,090. These ones I like to think of the example. So if they lend me $1, the amount that I owe them is going to be $1 and a penny after 1 day, right? After 2 days, it's going to be 2 cents, right? So it's going to be, you owe them $1.02 after 2 days. I don't know if you can start seeing the resemblance or the pattern. So after t days, it is going to be 1 plus 0.01 times t to get that formula. For 1.5, when the interest is calculated on original principal, only it is called a simple interest. Accumulated interest from prior period is not used in calculations for the following periods. In this case, the amount value A, the principal P, the period of investment T, and the annual interest rate I are related by the formula A equals P plus IT. At what rate will 500 be accumulated to 615 in 2.5 years? So in this question, you're looking for a rate, which is your interest rate. So this is what we're looking for. And they give you A equals P1 plus IT. They say that it is going to be 2.5 years. So we know that T is equal to 2.5. We know that P is your principal. So that's going to be your 500, because that's how much we started off with. And we know that A is equal to 615. So using all that, we just plug it in. 615 is equal to 500. 1 plus I times 2.5. We're going to distribute that 500. So this is 615 equals 500 plus 1250 I. So this is equal to, bringing a 500 on the other side, 115 is equal to 1250 I. Dividing 1250 on each side, you get I is equal to 0.092 or 9.2%. Alright, 1.6, using the formula given in the previous problem, which is A equals P1 plus IT. How many years? So this time we're looking for T. Will the 500 accumulate to 630 if the annual interest rate is 7.8? So your A is going to be equal to 630. Your principal amount is equal to 500. And we know that the rate is 7.8. So we just plug in chug. 630 equals 500. 1 plus 7 it's 0.078 because we gotta, this is 7.8%, so that's 0.078 t. As always, I'm gonna distribute the 500 plus 39t is what we get, is equal to 630. So that, subtracting 500 on each side, you get 130 equals 39t. So t is equal to 3.33 years. So 1.7 actually introduces the compound interest. So in this case, we have the formula a equals p parentheses 1 plus I to the tth power, and we call I yearly compounded interest. You can think of compounded interest as a series of back-to-back simple interest contracts. So basically, like, the amount of interest rates from the previous gets multiplied. So the interest earned in each period is added to the principal of the previous period to become the principal for the next period. So let's say you borrow, we're going to write this formula down real quick. A is equal to P I plus 1 plus I to the tth power. Let's say you borrow $10,000 for 3 years at 5% annual interest rate, compounded annually. What is the amount of value at the end of the 3 years? So we're basically just asking for A. We're looking for A here. Principal amount here is going to be $10,000. Interest rate we said was 5%, which is 0.05. T is going to be 3 years. So we just plug and chug. A equals 10,000, 1 plus 0.05 to the third power. So putting this all into the calculator, you get A is equal to 11576.25. Using the compound interest for 1.8, what principal does the Andrew need to invest at 15% annually? So interest rate is going to be 15%. So that he ends up with 10,000 at the end of 5 years. So T is going to be 5 years. And we're looking at how much is the principal going to be for the ending to be $10,000. Alright, so this is like reverse of the formula we used before. 10,000 equals principal 1 plus 0.15 to the 5th power. So this is 10,000 equals P 1 plus 1.5 to the 5th. So I'm going to divide this 10,000 by the 1.15 to the 5th power. You get that P is equal to 4971.76. So this is how much money you needed initially to get $10,000 at the end of 5 years, compounding annually. Alright, 1.9, using the compound interest formula. So this is kind of easy because they tell you what formulas to use. But for 1.9, what annual interest rate, so we're looking for the interest rate, would cause an investment of $5,000. So initial principal is going to be $5,000 to increase to $7,000, and T equals 5 years. So noting our formula, A equals P 1 plus interest rate to the T. A is 7,000 equals 5,000. 1 plus I to the 5th power. We're going to divide by 5,000 first. So you get 7/5 equals 1 plus I to the 5th. So we're going to, take this, not square root, but like the 5th power. And you're going to, after we do that, we subtract 1. So 5 root to the 7/5 minus 1 equals I. So then the interest rate is 0.0696, or it is equal to 6.96%. 1.10, using compound interest rate formula, how long would it take? So we're looking for the T. So initial amount P is equal to 15,000, and you want it to increase to 45,000, compounding annually at the interest rate of 2%. So using our formula, A equals P 1 plus I to the tth power. This is going to be equal to 45,000 equals 15,000. 1 plus 0.02 to the tth power. Okay, so then we're going to divide by 1500 first. So 45 divided by 15 equals 1.02 to the teeth power. So we'll take a natural log of both sides. So natural log of 3 is equal to t natural log of 1.02 by the natural log rule, so we can bring that t down. So this is equal to natural log of 3 divided by natural log of 1.02, which is equal to t. So then t is equal to 55.478 years. For 1.11, you have 10,000 to invest now and are being offered 22,500 after 10 years. So t is equal to 10 years. Initial amount is 10,000. Initial is p here. And you're offered, the final is 22,500 after 10 years as the return of investment. The market rate is 10% compounded interest. So that is going to be, interest is 10%. Ignore complications such as effective taxation, reliability of the company. Do you accept the investment? We're being asked, do you accept this investment? So we're trying to see if, using our formula, a equals p 1 plus I to the teeth power, if it actually does equal 22,500. So this is going to be equal to 10,000. We're just trying to see if the market is 10%. In 10 years, would it actually be equal to 22,500? So it's 25,937, and the amount is 22,000 that they're promising. So because this is less than that number, I probably would not accept. I would probably not accept it because I can make 26,000, close to 26,000 at the market rate. So their investment firm is not as effective as the market. Alright, 1.12. Suppose that the annual interest rate changes from one year to the next. Let I1 be the interest rate for the first year, I2 be the second year, and so on. What will be the amount value of an investment of P at the end of the 9th year? So how I would think about this is like for year 1, it's basically just a simple interest rate, right? So that we learn that to be P times 1 plus IT for year 1. So where was I? 1.12. So in year 1, it's going to be P times 1 point, the interest rate, which is I1, right, for year 1. Year 2, since it's compounded, it's whatever this amount is times the interest rate. But because we want to make sure that we want to include the principal amount, it's going to be 1 plus I1 times 1 plus I2. For year 3, it's going to be equal to the same thing, like the previous year's interest, previous year's principal amount. So it's going to be I1, 1 plus I2, times this year's principal and interest rate. So it's going to be 1 plus I3. And then so on. For year N, it is going to be equal to P 1 plus I1, 1 plus I2, and it's going to be 1 plus I to the nth power. The interest rate at the nth year. Alright, so for 1.13, they introducing discount. What interest discounting is? Discount is the process of finding the present value of an amount of cash at some future date. So by the present value, we mean the principal that must be invested now in order to achieve desired accumulated value over a specified period of time. So find the present value. So basically, we're using our formula A equals P1 plus interest rate to the t power, because it's compounding interest rate. And we're basically asked to find this value. If you're asked to find the present value, like how much money do you need to put in to have $100 in the future? So in the future, we want $100. We're looking for P1 plus the interest rate. Interest rate is 12% in 5 years. So then this becomes an easy problem. It's basically 100 divided by 1.12 to the 5th power, which is equal to $56.74. Question 1.14 asks that if you deposit $1,000 into the saving account, so principal is equal to 1,000, that pays annual interest rate of 4%, 0.4% compounded quarterly. So in 1 year, how much would it be? So in 1 year, it's going to compound 4 times, right? Because it's compounded every 3 months, compounded quarterly. And because the annual rate is 0.4%, or this is equal to 0.004, right? Then the quarter rate, every quarter you're going to actually get, the rate is going to be 0.004 divided by 4. That's going to be your quarter interest rate, okay? And that amount gets compounded, so we got to use our compounding formula, which is equal to A equals P 1 plus interest rate to the tth power. And we know that this is equal to $1,000. Our quarter rate is going to be 1 plus 0.004 divided by 4. And how many times does that get compounded in a year? 4 times. So we're going to raise it to the 4th power. So then this is equal to 1004.006, which is approximately equal to 1004.01 for part A. Part B, what is the interest earned over the year period? The interest rate, our later one minus our initial. So then in our case, it's going to be 1004.01 minus 1,000. So that's equal to $4.01. And part C, the effective interest rate is equal to the 4.101 divided by our initial, which is 1,000. So this is equal to 0.00401 or 0.401%. And you're wondering, why is the effective rate different than the annual interest rate? And that's because the annual interest rate doesn't take into consideration that it is compounded. So every month you're actually making more money than the annual interest rate. Alright, 1.15. The process of finding the present value of an amount A due at the end of the year is called discounting. The difference A minus P is called the discount on A. Notice that the discount on A is also the interest on P. For example, if $1,150 is the discounted value of $1,250 due at the end of 7 months, the discount on $1,250 is $100. What is the interest on 1150 for the same period of... Okay, this one's kind of tricky, but also easy. Okay, you know that the discount on A is the same as the discount on A is also the interest on P. So if the discount on 1250 is 100, then the interest is also 100. Alright, I hope you found this lesson 1 helpful. Make sure you like, subscribe, and share. Bye!